Okay, we're ready for the last section on identities. This is section 5-6. It is on half-angle identities. So we have a bunch of those again. You'll recognize them right away, just like we recognize the double angles when you saw 2a or 2 theta. The half angles, you'll see a over 2 or theta over 2 or x over 2. That's how you know it's a half angle. Notice these all have fractions in them, and they almost all have square roots in them. So you have one for the cosine of half of a, so it's plus or minus the square root of 1 plus cosine a over 2. You have one for the sine of a half a, that's a plus or minus the square root of 1 minus cosine a over 2. Then you have 3 for tangent. You have the tangent of half a is plus or minus the square root of 1 minus cosine a over 1 plus cosine a, or you have the tangent of half a equals sine a over 1 plus cosine a, or you have the tangent of half a equals 1 minus cosine a over sine a. Just like we did for the double angles for cosine, for tangent, just use whichever, sometimes it's whichever one you want, most of the times it's like that, or whichever one fits the best. If I have a choice, I tend to use this one just because I like it that it doesn't have a square root around it, and the bottom is a single thing. That makes it nicer to me for common denominator stuff. But it really doesn't always matter. It's just your preference. All right. Now to use these, we're going to use these in 2 or 3 different areas. One is just to find the measure of angles. And we've done this before. This is just another way to do it. Like this one is, this first practice problem says, find the cosine of 15. Well, we've done that before using like 45 minus 30. But we can also use a half angle. What you want to ask yourself is 15 half of an angle we know? Well, isn't 15 half of 30? So we want to think of 15 as 30 over 2, or half of 30. So if we want to do the cosine of 15, if we think of that as the cosine of 30 over 2, now we can use the half angle formula. Now that just means A is 30. So we go to our identity for half angle. Well, the cosine one looks like that. We're just going to put 30 in place of A. Since it's A over 2, that's in this case, that's 30 over 2. So we're putting 30 in for A. So if we do that here, we're going to have plus or minus the square root of 1 plus cosine 30 all over 2. Now we can get rid of the plus or minus because we're doing a 15-degree angle. That's in the first quadrant, so we know it's positive. So we know this one's positive right off the bat. Well, now we use 30 because we know the cosine of 30. Remember from our triangle, in our 30, 60, 90 triangle, opposite 30 is always 1. The other leg is radical 3. The hypotenuse is 2. So the cosine of 30 is radical 3 over 2. So we're going to substitute that in here. So that equals the square root of 1 plus radical 3 over 2 all over 2. So in place of cosine 30, we put radical 3 over 2. Well, now we have some work to do because we have a fraction within a fraction. So first, we need to get a common denominator over the top. Well, if we think of 1 as 2 over 2, the top becomes 2 plus radical 3 all over 2. Because that's 2 over 2 plus radical 3 over 2 is just 2 plus radical 3 all over 2. Now, here we have this complex fraction. Remember on those, we take the top times the reciprocal of the bottom. Well, that top becomes 2 plus radical 3 times 1. 2 times 2 is 4. Now remember, to simplify a square root, we can always put the square root over the top and the bottom. So here, the square root of the top, we can't do anything with that. So it looks weird, but there's a radical within a radical. The bottom, we know the square root of 4 is 2. And so that's our answer. So we looked and said, okay, 15 is half of what? Well, it's half of 30. So A was 30, we plugged that in. We knew the cosine of 30, then we had to do some work with the fractions. it's a real indicator when you get one like this next one where it says the tangent of 22.5. Well, that 0.5 is a real indicator that we have to use a half angle. So we can think of 22.5 is half of 45. That's what we want to think here. 22.5 is half of 45. So this is the tangent. If 22.5 is 45 over 2. So that's our A again. So we can use any one of our identities we want. Again, I like the third one. So here, I like this one right here, so I'm going to go ahead and use that one. So if we use that one, it's 1 minus cosine A. Well, here A is 45 over sine A, so sine of 45. So we just took our identity and plugged 45 in for A. Now remember, on a 45, 45, 90 triangle, if our legs are 1, 1, the hypotenuse is radical 2. So the cosine of 45 is 1 over radical 2. The sine of 45 is also 1 over radical 2. So when we plug in, we get that. Well, now to simplify that, again, if we get a common denominator on the top, well, the common denominator would be radical 2. So we think of 1 as radical 2 over radical 2. So the top would be radical 2 minus 1 all over radical 2. So it looks like that. Well, now when we take the top times the reciprocal of the bottom, well, we can divide top and bottom by radical 2, and we end up with radical 2 minus 1. And this is one of those, if you use one of the other two identities for tangent, your answer might look completely different from this. It doesn't make sense wrong. It just looks different. It's actually the same thing. Okay? Now this next one, we want to simplify that fraction that's given. Now when you look at that, when I see that square root, I think, does that look like the right side of an identity? Well, let's look at our identities. Do we have any of them for half angles that look like the square root of 1 plus cosine over 2? Well, when I look at that, that looks a lot like this very first one right here. You see it's 1 plus cosine over 2. So it matches with that. Now the next thing is, what's A? Well, you can see A is in the same spot as the 12x. So A equals 12x. Well, if that matches the right side of the identity, it has to equal the left side. So that has to equal our left side is the cosine of A over 2. We said A was 12x, so it's the cosine of 12x over 2. We can simplify that a little bit to just cosine of 6x. So we look at that and just look for something on your identity sheet that it matches. Or let's go down to this next one. 1 minus cosine of 5 alpha over sine of 5 alpha. Again, look at the identity sheet. Do we see any that look like that? Let's see, 1 minus cosine over sine. That looks a lot like this third one for tangent. Can you see that those two look alike? 1 minus cosine over sine. So the next thing is, what's A match up with? Well, it looks like A matches with 5 alpha. Well, if that matches the right side of the identity, it has to equal the left side. So this equals the tangent of A over 2. Well, we said A was 5 alpha. So we have 5 alpha over 2, and that's all we can do with that. We can't go any simpler than that. So again, look at that and just try to match it with something on your identity sheet. Okay? This next one is a verify problem. And one, there's a typo on that. It's supposed to be a 2 on top here. So on top of that fraction, that was supposed to be a 2, not a 1. And, no, I think that's all. No, and this should be over 2. There's 2 typos on that one, so it should look like that. So it should be a 2 on top of the fraction. That should be the tangent squared of x over 2. Okay? Now, again, when you see this x over 2, that should scream out half angle, half angle. So we look at our half angle ones and see which one do we want to use. Well, one, because this is squared, this is a good time to use one of the square root ones. So we have we only have one square root one. So if I use that one, again, that's because if this is squared, that works out great with this square root, because if you square root, it gets rid of that. So I leave this first part alone, so that's 2 over 1 plus cosine x minus, now if we use this one, we're going to square that, so it's going to be 1 minus cosine x over 1 plus cosine x. Okay, so again, we chose that because it's a half angle, and because it's squared, we use the one for tangent that has a square root, because that gets rid of the square root right away. Well, now, if you notice, we have a common denominator. So we're going to take 2 minus all of that second one. So it looks like that. Well, now if we distribute, that's going to be a negative 1 and a positive cosine x. So that's 2 minus 1 is 1 plus cosine x over 1 plus cosine x. Well, the top and bottom are the same, so that's just 1, and we verified it. Okay. Number 6, this is kind of the reverse of the double angle ones. Here, we could have done this using a double angle, which I would probably do, but you can also use it for a half angle. Because here, we're trying to find the cosine of theta, and they gave us the cosine of 2 theta. Well, could we think of theta as 2 theta over 2? Wouldn't that be the same thing? So this cosine of theta, let's think of that as the cosine of 2 theta over 2. So that's a half angle identity, and on the top, that 2 theta is A. So let's go to our identity sheet and use the half angle for cosine. That's that top one there. So that equals, now notice it says we're in quadrant 2. It says theta is in quadrant 2. Well, in quadrant 2, cosine is negative. So where it says plus or minus, we're going to put a minus. Then we're just going to use that identity. So it's 1 plus cosine A. Well, here we said A was 2 theta. So it looks like that. So all we did was take that identity and put 2 theta in for A. So we have that. Well, now let's see. We have a negative. They told us the cosine of 2 theta is 1/2. So on the top, we have 1 plus 1/2 all over 2. Well, let's see if we can simplify it. Keep the negative. So now the top is 1 plus 1/2 is 3/2 over 2. Now if we take the top times the reciprocal of the bottom, that gives us negative square root of 3 times 1 is 3, 2 times 2 is 4. Now remember, with a radical, we can do top and bottom. So we have a negative. Well, the top is the square root of 3. We don't know what that is. But the bottom, the square root of 4 is 2. So we get negative square root of 3 over 2. This next one, now this would be obvious using a half angle because they gave us the cosine of s, and we're trying to find cosine of s over 2, the sine of s over 2, and the tangent of s over 2. So just like those other problems we've done like this, the first thing we start off with is, let's see, if we want to find the cosine of s over 2, let's look at our sheet and write down the identity. Well, the cosine of s over 2 is plus or minus the square root of 1 plus cosine s all over 2. Now notice it says s, here you have to do a little work. Let's go over here. It says, let's write this out, as 3 pi over 2 is less than s is less than 2 pi. Well, we're trying to find half s. Here it tells us where s is at. Where's half s? Well, what if we wanted to turn s into half s, wouldn't we just divide by 2? Well, let's divide by 2 all the way across. So now 3 pi over 2 divided by 2 is 3 pi over 4. And 2 pi over 2 divided by pi. So that means s over 2 is between 3/4 pi and pi. Well, that puts us in the second quadrant. So that's how we know we're in the second quadrant. Well, in the second quadrant, cosine is negative. So we wrote out our identity. Now we substitute in. We have negative square root of 1 plus, it says the cosine of s is 2/3, so we put 2/3 in for the cosine of s. Let's see, on the top, that's negative square root 1 plus 2/3, that's 3/3 plus 2/3 is 5/3 divided by 2. If we take the top times the reciprocal of the bottom, that's negative square root of 5/6. You can leave it like that, or you can make it negative radical 5 over radical 6, or if you don't like radicals on the bottom, you can take top and bottom times radical 6. That'd be negative radical 30/6. Any of those would be fine answers. Okay, then it asks us to find the sine of s/2. Well, again, we look at our identity sheet, write out the identity. Now, it starts with plus or minus. We're in quadrant 2. In quadrant 2, sine is positive. So we take that our identity, and that's going to be the square root of 1 minus cosine s all over 2. Again, we know cosine s is 2/3, so we have 1 minus 2/3 over 2. Well, that's 3/3 minus 2/3 is 1/3. So it's 1/3 over 2. Now if we take the top times the reciprocal of the bottom, that's the square root of 1/6, which you could make 1 over the square root of 6, or if you take top and bottom times radical 6, it'd be radical 6/6. Any of those are good answers. Then the last one, for the tangent of s/2, you could use the identity. I like going back, since I already found the first two. We know tangent equals sine over cosine. So that's the sine of s/2 over the cosine of s/2. Well, since we already found those, let's see, the sine of s/2 was 1 over radical 6. The cosine of s/2 was negative radical 5 over radical 6. Well, now if we take the top times the reciprocal of the bottom, we can divide top and bottom by radical 6. Lost my radical. We get negative 1 over radical 5. Or you could make that radical 5 over 5, negative radical 5 over 5 if you want. Okay? So that's using the half angle identities.